Hello everyone and welcome back to this next lecture. So in the previous lecture we had successfully compiled our project. Now it is time to execute this project on the microcontroller and view the results. It is quite possible that there will be errors, but we will figure out how to fix those errors as well. So with this I am going to bring the microcontroller into the video, and this time there is not just the microcontroller and the breadboard, there is also the oscilloscope. Because remember, there is one timer with a 1 millisecond time interval, and that can only be viewed on the oscilloscope. So you can see the microcontroller in the video, and as you can see there is also an oscilloscope that has been added. Now most of the connections are the same except for this one additional connection from PA11, and I have taken it out to this wire where I am taking it out as a connection which I can view on the oscilloscope probe. So with this done, let us now download our code onto the microcontroller. So for that I am going to just use this button and say make and program device. And the program is complete. So for example, we see that LEDs are glowing, but quite strangely they are not flashing the way they are expected, right? Except for this white LED which seems not to be glowing at all. The yellow, the red, the blue and the red LEDs are glowing constantly. We would have expected these LEDs to flash at 1 second and 0.5 seconds, because this is what I have used for this particular, and now you see the white LED has started glowing. So therefore one timer is working correctly, because the timer that is the GPIO pin that is connected to this white LED is connected to the 30-second timer, and apparently that is working correctly. So therefore we must find out what is happening with the other two. So for that reason let me zoom into the oscilloscope, and you will see I have connected two probes to the two GPIO pins which are connected to the two timers, which are TC2 and TC3. So we would have expected these two timers to have a much larger time period, because we have configured them for 0.5 seconds and 1 second. But if you take a look, the two waveforms are almost overlapping, and moreover they have a time period of just 1 millisecond. So therefore quite obviously there is something wrong with our configuration. So I am going to end this microcontroller video, and I will go back and try to fix whatever error is there in our control code. So now back in our control code, we must examine what's happening with these configurations. So let us go to TC2. Now if you take a look at TC2, we will find that we are generating some waveform. So therefore it is clear that what is happening is that we are somehow not able to generate the correct period. So let us look at what could be, and for that reason there are several possibilities. One is we might have not correctly chosen the prescale, or we might have not correctly chosen the timer counter. So therefore if you look at the timer counter, it is fairly large. This is corresponding to 0.5 seconds, and therefore this is a mistake in the comment, TC2, and therefore let us look at the prescale value. So this prescale value is 0x7 because we want to divide the clock by 1024. So let's go back and check what's our documentation, what that means. So if you look at the prescaler are these 3 bits. And if you take a look, if we want to specify 1024, we do have to specify 0x7, right? That's what is there from this. But it's important to remember that we must not just specify 0x7. We have to specify 00 for these two lower bits, because we are writing a UN32, that is we are writing a 32-bit unsigned integer. But what we have written here is clearly wrong. We have just written 0x7. So therefore we must add 2 zeros here, right? Only then can it be a valid prescale. Without these 2 zeros we are actually setting these 3 lower bits, which is completely wrong, because that means we are enabling it. We are resetting our timer module, and we are enabling it, which is totally not what we want to do, right? And that is the reason why this is completely failing, because we are making a spurious write to these bits. So let's go back and fix this, and we probably will have to fix this in others as well. I'll go to TC3, also the same issue. add these two, and let's check out TC4. So TC4 doesn't have a prescale, so therefore there's nothing to change. So with this, let us do another compile. And the compile is successful. And with this, let me bring my microcontroller back into the video. So you can see the microcontroller, it's in the same state it was before. There is this white LED which is flashing, but the other two LEDs are steady. So I'm now going to program this. So I'll use the other button or the other option through the menu function. And now you see the program seems to be working. The red LED is flashing at 0.5 seconds, the blue LED is flashing at 1 second, and this white LED will still be flashing at 30 seconds. It probably will come on soon because it still has a 30-second timer. So now what I'm going to do is I'm going to zoom in on the oscilloscope, but I'm going to first check whether I am taking the correct measurement, because until now I had connected the oscilloscope and now you see the white LED has also started glowing. So therefore we have got our connections correct. Now what I'm going to do is I'm going to connect an oscilloscope probe to the GPIO 11 or rather PA11, because that is what we are using as a 1 millisecond timer. So let me go and connect it there. So let me zoom in on the oscilloscope. So you can see the oscilloscope now has a 1 millisecond timer, right? This is exactly 1 millisecond, what we wanted. And if you take a look, the time period is 1 second and 1 millisecond, sorry, and each rectangular waveform has exactly 1 millisecond in width. That means in time interval. So therefore we have managed to configure all our timers exactly as we wanted. So we can come down and have a look, and yes, you see the LEDs are still flashing. So I hope you got exactly the same results. Of course, if you created this, if you wrote the program along with me, you would have the same bug and you would have to fix that bug. But if you arrived at these results, you have now managed to set up your timer counter. So I'm going to end the microcontroller video. And with this, we can also end this lecture. So in this lecture, we have successfully configured 4 timer counters, because in this case, we had chosen a 32-bit counter comprising of 2 counter timer modules, that is TC0 and TC1. So we could have used 5 timer counters, but because we chose a 32-bit counter, we have only 4 counters that we can use. But with these 4 counters, we managed to establish time intervals that are drastically different. So for example, we managed to establish a time interval of just 1 millisecond, and we managed to establish a time interval of 30 seconds. And as I said, I would leave this to you as a challenge, but you can even extend this further and look for time intervals in hours or several minutes, because that will only mean that you need to use a prescaler, or you may need to set up another generic clock generator in order to generate a smaller clock. Because remember, you can not only divide the clock at the counter, but you can also divide the clock at the generic GCLK generator, and therefore the clock input to the timer counter can also be much slower. So these are several options that you have, and I would suggest go ahead, try to experiment with them. And as I said, the reason why this is so important is because in power electronics, you may have to establish separate control loops which are totally independent from your pulse width modulation. For us most of us power electronics people, we are interested in controlling the converter, and most of us will use PWM in order to execute a control loop once every PWM cycle. But there are certain other control loops which may be totally independent, things like temperature control, pressure control, maybe even voltage control or something else, frequency control, things which are much slower. and for which you cannot use fast controls such as the ones implemented with our pulse width modulation. And for that reason, you can use timer counters in order to be able to set totally different time intervals with which you can implement your control algorithms. So this gives you the flexibility as a power electronics engineer to implement your control algorithms, and these control algorithms will simply be implemented inside the interrupt service routine. Of course, here we are doing a very simple thing. We are merely toggling LEDs, but in reality, you will be actually running control algorithms in this. These could be PID controllers, it could be anything else, it could be even just simple monitoring. All this is possible in these interrupt service algorithms. So, if you have any other doubts, or you had any issues, or something didn't work, you didn't get these results, that is, you couldn't get flashing LEDs, or you were trying something else and that didn't work, whatever may be the case, please post in the Q&A forum and I'll be happy to help you out. Otherwise, I will see you in the next lecture where we will conclude on this section. Thank you so much for listening and goodbye for now.